Hello, my dear students. This is Mrs. Numaira Zahid, and here we are going to learn about the relationship among velocity, frequency, and wavelength of a wave. So as we know that these are the three main important properties or characteristics of waves. So let's find out what are these three values. As we know that we are going to derive this relationship, and how can we derive this relationship? How can we understand and apply this relationship to solve many numerical problems in our physics syllabi? So this V is related to velocity of the wave, and F is actually the frequency of wave, and lambda, which is the Greek letter, is used to express the wavelength of the wave. Okay, so how these three quantities are related to each other? As we know that frequency is inverse of time period, and the relation expresses that velocity is directly related to frequency and its wavelength. So whenever we are going to find out velocity, we need to find frequency and wavelength of the wave. But remember that frequency and time period are always inversely related. So whenever you are replacing f, this frequency with time period, it will become lambda over t. So there may be two types of numerical problems. Number one, it can be mentioned as, if it is given that find velocity, that is V is equal to question mark, if the wavelength of the wave is 20 meters and its frequency is 40 hertz. Okay, so here we know that velocity is unknown value, and we are given with a wavelength of 20 meters along with the frequency of 40 hertz. These are the supposed values, okay, arbitrary values. So whenever we want to find an unknown value from a relation, first we need to find what relation are we going to use. Here we are applying the relation, and for finding V, we have to multiply frequency by the value of wavelength. So it becomes 800 meters per second, because meter per second is the unit for velocity of a wave. So from this relation, we are able to find the velocity of a wave if we know the frequency and wavelength. But we can also find frequency and wavelength in another situation if it is given that the velocity of a wave is 20 meter per second. Find its frequency if its wavelength is 10 meters. So applying the same relation, V is equal to F lambda, we can find that frequency is the unknown value, and we can make it the subject when we make 10 as the denominator of 20. So frequency can be 2 hertz. This is how we can find frequency of a wave if we know the value of its velocity and wavelength. Now, if we want to find out the value of wavelength from the relationship, given that find lambda or the wavelength when frequency of a given wave is 20 hertz and its velocity is 10 meter per second. So what can we do? Using the same relationship, we are going to find out the value of lambda. So in order to make lambda as the subject, we need to divide velocity by frequency. Here, lambda is equal to V over F, that is 10 over 20. It becomes 1 upon 2 or 0.5 meters. Hence, we have got the value of wavelength as well. All right. But if in case the frequency is not known and it is given that find lambda, that is the wavelength of a wave if time period is 2 seconds, time period of the wave is 2 seconds, and its velocity is 10 meter per second. How can we find wavelength? As we have the value V is equal to F lambda, the value of V is known, the value of lambda is unknown, and we don't know the frequency. We have to put the frequency here. So we will replace this frequency with time period, but always remember that frequency is inverse of time period, or time period is inverse of frequency. So we can find out that F can be replaced with T and lambda. Now, can we put the values? Velocity is 10, time is 2 into lambda. What will happen in order to make lambda as the subject? This 2 will multiply 10 and 10 2 times is 20. So lambda is equal to 20 meters. This is how we can manipulate this value, this relation in terms of time period. Okay. And if in another situation, there is another situation, if it is asked that find time period of a wave when the velocity of the wave is 10 meter per second, its wavelength is 10 meters, and its frequency is 20 hertz. What can we do? Now we are finding time period and we have all three values. So actually in this case, we do not need these two values. These two values are just to confuse the student, and here we just need to know what is the value of frequency. As we know that time period is inverse of frequency, we will say the time period is 1 upon f, which is 1 upon 20. With the simplification, you can get time period in seconds. Got it? It is really very simple. Okay. If you like this video and if you have learned something from it, kindly share it with your friends. Thank you.